Hi everyone, today we're going to be talking about sedimentary rocks, specifically sandstone, as systems and how we can view the deposition and weathering or deteriorating and erosion of sedimentary rocks as a system. So we have some sedimentary rocks here, and the reason that sedimentary rocks are distinct from, say, metamorphic rocks or igneous rocks in the rock cycle is because of the way that they are created. So sedimentary rocks are actually cemented generally clasts of previous rocks. So for example, here we have a sandstone, and a sandstone is a cemented together rock normally consisting of silica or quartz particles. And those are going to be, we'll talk about later how those are created and cemented together. We also have things like shale, which are deposited in low energy environments. And similar to shale, we have siltstone, which is also a smaller particle that's been cemented together and are created in low energy environments as well. We also have rocks like coal, which is a rock made up of carbon that you often find in thin layers that has been condensed. It's been organic material that's been condensed over time so that only carbon remains. Things like gypsum, which is an evaporite, consisting of salt that's been evaporated from, say, a lake. And then things like breccian conglomerate, limestone, and there's other kinds of limestones like coquina limestone and oolitic limestone, which were previously organic material that cemented together. So today in particular, we're going to be talking about sandstone, as I said earlier. Let's get started talking about why sandstone is so interesting. So here we see the different depositional environments for sedimentary rocks. Present is the aeolian environment, which you can see there producing dunes, which occurs in the desert from wind sweeping over the sand in the desert and pushing sand into dune formations, but then also the fluvial environment there in the river systems. Sandstone is formed both in aeolian environments, obviously, because dunes are made from sand, and also in fluvial environments. When the energy is correct in a fluvial environment, sand is precipitated out of the water and settles on the bottom of the river. After the sand settles out of the water, the sand is compressed down into place, and then cemented by most likely a calcite or something like that. Here in this image, we see the sand particles compressing down on each other and water moving through the pore spaces between the sand. This water carries small calcite particles, and the calcite is precipitated out of the water and cements the sand in place. So how can we start to think of sandstone as a system? Well, if we think about the precipitation of sand out of the water in a river onto the riverbed, we can think about that as our inflow. Precipitation of the sand out of the water is an inflow of sand into our stock, which becomes a sandstone. As the sand on the riverbed goes through the process of cementation, compaction, and then cementation, we can think about that as becoming our stock. So the inflow is precipitation of sand out of the water, and our stock becomes the actual sandstone that is created after the cementation process. So what's the outflow in this situation? How can we start to think about sand flowing out of this sandstone system and creating an outflow for our system? The best way for us to define outflow in our sandstone system is by erosion. Here we see a sandstone outcrop that at one point would have been a large sandstone face and has now been eroded into a single column. Another important feature to note here is the cracking. The cracking on the sandstone would have been created by a process called weathering. Weathering can occur in a few different ways. The most common way is for water to enter into pore spaces, especially in sandstone, and erode away the cement material that holds the sand particles together. Water can also cause damage to an outcrop by entering cracks in the rock and freezing and thawing, and over time weakening the entire rock face and allowing parts to fall away. In this picture here, we see that water would have run through the topography here, eroding holes into the outcrop and creating the face that we see here. This removes sandy material from our sandstone and creates the outflow that we know as erosion. So, we've now defined our sandstone system as having the inflow of sand being precipitated out of the river water onto the riverbed, and then after some time, this sand that's present in our stock is cemented and creates our stock known as sandstone, the actual physical rock that forms from the cementation of sand particles. The outflow for this system, as we discussed, is erosion. And erosion is affected by the amount of weathering that happens to sandstone, but it can also be affected by how well cemented the sandstone is. A really well cemented sandstone such as this one that we looked at a little earlier, is not going to fall apart as easily as, say, a poorly sorted sandstone, something that isn't cemented together well. So erosion rate can be affected by the cementation and also the amount of weathering that something has undergone. And our system has now been defined as having inflows, outflows, and also a stock. So I think it's interesting to consider rocks as real environmental systems in the same way that we would consider animal populations in an ecological system or plant growth over an area. Rocks are just as dynamic even though their growing and decaying process occurs over a longer time. The Earth is a very dynamic system, and I think it's important to understand rocks like sandstone as systems. Thanks for learning about sandstone with me today. I'm Callum Wayman. Thanks for watching.